In this video, I would like to provide you with the information regarding cost-benefit analysis and price sensitivity analysis using net present value method and Monte Carlo simulations. Welcome to the second video. The cost-benefit analysis is achieved by calculating net present value for a given system for next 15 years. The green cells over here are the user-defined cells. The user can input relevant values and see the final net present value after 15 years. The following graphs are helpful to the user to visualize the net present value for 15 years. The user can also define the heat exchanger duty on F column. The operating cost and the direct labor cost will be calculated depending on the user-defined heat exchanger duty. The operating cost will also be calculated with the help of pressure losses we obtain from the sizing worksheet. For this particular investment, we can see that the NPV is negative. The parenthesis in accounting means negative value. Even if NPV is negative, it does not mean that investment is not profitable. Instead, it means that we are not making enough profit due to either interest rate or some operating parameters. If we reduce the maintenance costs and if we reduce the number of working operators, we can see the NPV has risen steadily in upward direction and the final NPV is also positive. The price sensitivity analysis can be done by running Monte Carlo simulation. In this simulation, we have assigned the important factors with different types of probability distribution. In this, the user can manipulate the data and see how the simulations will run for 1,000 different scenarios. The user can define investment costs from 3 different suppliers. The user can also define working wages for 3 different class of workers, for example, trainees, technical operator, highly skilled operators. The user can also define maintenance costs from low to the highest. The user can also define electricity costs depending on the geographical location. The sales revenue can also be defined depending on the past history of the company. The taxes paid by the company can also be defined here, and the interest rates can also be assumed. Once all the relevant factors have been assumed or entered, the user can click on Execute Monte Carlo. Depending on the computer speed and processing capacity, the Monte Carlo simulation will take 240 to 300 seconds. For this particular scenario, we have received 87% positive NPV result. Press OK. In this chart, we can see out of 1,000 different scenarios, 850 scenarios were falling inside the positive NPV side, and other 150 scenarios were falling into negative NPV side. The 850 positive scenarios indicates that the user can go ahead and invest in this particular heat exchanger. If the number of operators are increased and we run the simulation again, we can see a different result. By increasing operators, we can see that 19% of the result were positive. This can be visualized in this histogram graph. Around 800 simulations ended with negative NPV result and 200 simulations ended with positive NPV result. This means that the investment will be risky for the user if there are 2 operators working for one particular heat exchanger. The user can manipulate more of this data to get different NPV results. Thank you very much. Have a good day.